Perfect. All right, so let's wrap this one. Slider block C moves along, moves at 8 meters per second down the inclined groove. Determine angular velocities of lengths AB and BC at the instant shown. All right, so basically we're going to need to find the W of A, and we're going to call this the W of B. Actually, that wouldn't be that way. It'd be like this, the W of B. So we got two of them. All right, so those are two separate rigid bodies that we're going to look at. So when you're doing two separate rigid bodies, this body's going to get its own instant center. This body's going to get its own instant center. Does that make some sense?
Yeah.
All right, dope. So what I'm going to do is I'm going to draw them arbitrarily because I know the physics. So when you know the physics, you can do this. I always start from the fixed axis point because it's obvious what the velocity is going to do. If this guy's going to push down like that, then that means the velocity of B has to be going. Actually, that's not a good color for this. Let me use green. The velocity of B has to be pointing straight down for this motion to happen for A. Does that make some sense?
Yep.
I don't know what the value is, but I do know the direction. And then obviously they told us that the velocity of B is going like that. Okay. So with that being said, all I have to do is draw my perpendiculars. Boom, boom. And this is the IC for BC. So I'll call it IC BC. Make some sense?
Yeah.
Easy stuff. So from there, here's our rule. This W is the same as the W on that wheel. Remember, for BC, now that we took a picture of it, we could see that being our circle, and points B and point C are now on a disk that's rotating together just for that instant. In real life, is it really like that? No, but they're behaving like that. And so we know is WB, the W of BC, we'll call it BC, so that way I'm not confusing myself, equals VB over RB, where this right here is RB. You follow me?
Yeah. So,
and then this right here is RC.
Well, so then I guess a quick question I would have, right, is that if you're doing it like that, so then for A, you consider, do you even, so you know how she has the angle there? Do you have to consider that angle when we're using IC or no?
You might. It's pure geometry. You have to find RB and RC, and that's going to be based on geometry.
Okay.
Yeah. Remember how for when we were doing it with the vectors, you always knew the position because of geometry. It's the exact same way here. You got to use triangles to figure it out. So you're probably gonna need that 45. Actually, yeah, you're gonna need that 45 because this right here is where the 45 goes.
Yeah, because sometimes I'll get confused because then I know she does like uses different angles, but I think I recognize that she just does like
law of complements.
Yeah.
Yeah, that's exactly what happens. So some people
when I should do that. That's when
yes, some people who hate the geometry, this method is not for the people who hate geometry. I'm not gonna lie to you. This method, if you are not good with like using the geometry, this method you can't do it because it takes you too long. It's easier to just use the vectors. However, forcing yourself to do this method over and over will make you good at geometry. Because remember, there are only 3 rules that you use. Pythagorean theorem, law of cosines, and law of sines. And then, of course, if you want to figure out what the actual angle is, you have to just use complements. So you draw out like 90-degree angles, and you just create complements until you move your angles around.
Okay.
So this right here would be my 45 degrees, just because if this is 45, then this is 45, and this triangle is isosceles, and so that has to be 45 by default. So that was my reasoning there. So it's a 45, 45, 90 triangle, which is great, which means that everything is going to be made easy. I know this arm right here is 2 because they told me that. That's the 2. So now I know one length, and I can find the others by just using cosine and sine. So VB equals VA over RA. So I need to find RB and RA because I know VC. Oh, I said VA. RA. I meant VC and RC. So basically, since I know VC, I just have to find this guy. Make some sense? And I find him with the geometry. And so it's easy enough to just say RC equals it would be that's the hypotenuse. So it would be sine of 45. I always mess this up. Let me just put the exact statement. It'd be sine of 45 equals 2 over RC. So RC equals 2 over the sine of 45. Sine of 45 is it 1 over square root of 2? I don't remember. Let me whatever. I'll just put it in my calculator. 2 divided by the sine of 45. That's 2.83. So that's 2.83. And now I just plug that back in there. Make some sense?
Mm-hmm.
And so easy enough to find WBC. The first arm is going to be 8 divided by 2.8. So 8 divided by my last answer, which is, wow, it's actually 2.8. 2.83 cubed, 2.83 squared is 8. Cool. So the answer is actually, and I'll just write it out so that it makes sense. 8 divided by 2.83, which actually is 2.83. And that's radians per second. Make some sense?
Yeah.
Boom, easy stuff. So now you found the second arm. And the only reason I found the second arm first was because it had the value that I needed. So I used this guy to determine that VB was moving down, and then I solved B and C. So now that I solved B and C, I can back solve and start to solve bar A. Does that make some sense?
Yeah.
Good. So if that's going to be the case, then RB is the same as RC because it's symmetric. RB equals RC. If RB and RC were not the same, that's okay. You would just use the W to find. You use geometry to find RB and then relate W to VB, which is what we're going to do right here. So we can say
that's what you're going to do with B in there. So
yep, VB equals WBC times RB. We know RB is 2 point whatever, and so it's got to be 2.83 times 2.83, which we know is going to be 8, because I just basically did that same thing backward because of the symmetry of the problem. So that's going to be 8 meters per second. And that is how you solve for VB. But that's not what we want. So let me actually not put that's not what I want to box up. VB is what we need to get to our next answer. So now we basically solved for the whole bar BC. Does that make some sense?
Yeah.
Great. So I'm going to erase all of this stuff that pertain to bar BC so that it's not messing up my description of bar AB now. So now I'm going to take a look at bar AB. And bar AB is fixed axis rotation automatically, so I don't even have to do an instant center because A is the instant center because it actually isn't moving. Does that make some sense?
Yes.
So when you're finding the instant center, you're finding the point that has zero velocity, and it's going to be outside of the two objects for general plane motion. But for fixed axis rotation, the point that has the zero velocity is inside of the body for fixed axis rotation. So I don't actually have to do. Technically, when you're doing fixed axis rotation, you are doing instant center. It's just that the instant center is automatically known. So this is the IC for bar AB. Does that make some sense?
Yeah.
All right, great. So that being said, I know that for this bar right here, boom, and I'll put it in the dark blue because it was already in dark blue. I'll say VB for this bar, VB equals WA times this distance right here, which is 2. Now, I want you to see something very particular. For this bar, this equation is how it works. VB equals WA times 2. But for this bar, VB equals WABC times RB. Okay. So VB has 2 renditions. It has the rendition where it's working on the vertical bar, and it has the rendition when it works on the horizontal bar. Does that make some sense?
Yeah, but wouldn't they be equivalent though?
Yes, that's exactly why this whole thing works, because they're equivalent. So basically, I'm just using this guy to back solve into that guy. So I'm solving for VB twice in a way.
Okay, okay. I thought that I was just making sure, but also I was thinking that it would be identical to VBC just because of the geometry being symmetric and the distance being the same on both sides.
Right? It might be. Yeah, no, it might be for sure. WA actually it looks like WA.
It was an isosceles triangle, so they both have the 45-degree angles.
Oh, hold on now. I see what you're saying. No, you are right. You're right. Yeah, it's going to be the same. WA looks like it's going to be the same. So,
We
yeah.
can solve it anyway, just in case, because I don't know.
To solve, we want to find the W. So W is going to be VB over 2. Actually, no, it's not going to be the same. VB is 8, so it's going to be 4. It's slightly faster. It's slightly faster because